Cardiac imaging is an essential part of residency education. However, experienced educators in cardiac imaging are relatively scarce. This presentation reviews our experience in using technology to extend the reach of educators even between institutions. ACGME program requirements for resident education include a requirement for training in cardiac over multiple modalities. Furthermore, the ABR certification exam, both historically and as a part of the exam of the future, include cardiac imaging as one of the required topics. Cardiac imaging fellowships, however, are relatively scarce compared to other more conventional training programs such as neuro or musculoskeletal. This is a graph depicting fellowship spots advertised at the ACR fellowship directory, and while not a scientific assessment of the number of trainee spots, serves to show an overall trend of relatively fewer cardiac positions. Our experience starts with our background of 3 separate facilities within a large metropolitan area. Residents at each of these facilities meet for a joint lecture at noontime, and the division of who gives the lectures is comprised from staff among each of the 3 separate facilities. Generally, 4 to 6 fellowship-trained staff were available to divide the lecture preparation and administration, and these are given over a video conference series. The method of cardiac education historically at our facility included topics being embedded within the chest, pediatrics, interventional, or nuclear medicine sections, however was limited due to suboptimal cross-correlation and coordination to ensure comprehensive coverage of topics. There was a dedicated block for cardiac imaging, however this was given by non-fellowship trained staff, and as such, newer concepts in CT and MR were not well represented. This presented an opportunity to use new technology to bridge the gap and extend the reach of cardiac education. This technology took the form of a learning management system which hosts and tracks educational resources, further providing pre- and post-course assessment and resident feedback. The learning management system is a software application for administering, creating, and tracking computer-based coursework. There are a number of commercial and open source options, of which we chose Moodle, which was an open source product that has a broad user base and support, is known for ease of use and robust media support. Furthermore, this has been proven in radiology education being presented at RSNA in years past. Educational resources to be used during the course were selected by the cardiac educator and included lectures, small group sessions, case series, as well as key articles. Lectures could be taken from a number of different sources, including original presentations created by the educator, subspecialty society presentations made available for public viewing online, as well as DVD-based lectures with appropriate provider permission. This is an example of a lecture being added to the learning management system, in this case, an original authored presentation embedded into YouTube and incorporated into the learning management system for resident review. Once incorporated into the LMS, the lecture is available for viewing on both conventional desktop and laptop computers, as well as on mobile devices such as the iPad, Android, or iPhone devices. Once a volume of lectures was incorporated into the LMS, each lecture was given an assigned time slot, and the LMS tracks when the resident accesses the lectures, serving as a form of attendance. Furthermore, each of our residents was required to submit 1 question on topics covered during each of the lectures. This is an example of the lecture schedule, showing that there are lectures assigned during each of the noon conferences that would conventionally be given, and following each lecture there is a link for an assignment wherein the resident can submit a written multiple choice or true-false question with an explanation of the concept behind the question. These are examples of questions submitted as a part of this assignment, and you can see that the resident was requested not only to provide the correct answer, but also an explanation as to why the correct answer was correct and why the others were incorrect. This facilitated residents thinking critically about the concepts that they were learning and attempting to find a way to explain it to others. The questions are then reviewed and graded by the cardiac educator, and in some cases a conversation started explaining and clarifying points that may have been misunderstood during the course itself. After lectures, small group sessions were scheduled through the LMS and included topics that were better facilitated to small group one-on-one interactions. Specifically, training at the workstation targeted towards both anatomy, and cardiac sections, as well as workflow, was performed with specific identified tasks that the residents were responsible for learning. After lectures and small group sessions, a case series was incorporated into the LMS. A vendor-supplied learning toolkit that included 50 unknown cardiac cases of both calcium score and coronary CTA was made available on the 3D workstation, and the histories and feedback were incorporated into the LMS, allowing tracking of the resident's progress. The goal for each resident was to complete the cardiac case series by the end of residency, and the LMS report would serve as documentation that the resident had reviewed those cases. This is an example page showing feedback that a resident would give after being presented the history and reviewing the case on the 3D workstation, and upon submission of their answers, the findings of the case and important teaching points were presented to the resident through the LMS. Finally, articles were incorporated into the LMS as a repository of key articles covering essential topics. These are made available as a reference for the residents during the course and afterwards, and certain articles are assigned as prerequisites to either the small group sessions or to certain lectures. The LMS tracks when the resident accesses each of the articles. Pre- and post-course assessment was performed in the form of exams that are composed of questions submitted by the residents during the lecture series. The pre-test was taken from questions from the prior cycle, and the post-test was taken from questions from the current cycle. This is an example of the multiple choice test, which may include true, false, multiple choice, as well as matching type answers. And upon submission, the resident is presented with the questions that they got incorrectly, as well as explanations of why the topics were correct or incorrect to further allow education at the time of assessment. The LMS provides immediate feedback to the residents. Statistics on both the resident and exam performance are automatically generated, and this data can be exported for the purpose of attendance and tracking. So how did we do? We found that our overall aggregate performance for our most recent cycle of residents went from an overall average of 6.4 on the pre-test to 8.6 on the post-test, with a large number of residents improving their performance. In conclusion, an LMS-based course can extend the reach of instruction by specialists who may be scarce. This type of instruction cannot, however, replace live case-based interaction with residents, and the target of our system was meant to facilitate didactic lecture. Live case-based instruction done each morning was not supplanted or replaced by this methodology. The system could be expanded to include other programs or specialties.